Okay, let's have a look at this statistics question. Okay, I found a lot of students are having trouble with statistics questions, usually because of the large amount of reading on the question. Now, this happens not only for international students, but also for local students. So the purpose of having this question is to develop the way of effectively pick up the useful information from the question. Okay, let's have a look at this. We have a consider price of any share in an oil and gas company that varies depending largely on the company's financial development. So in regarding to such a share, we let X be the ratio share price for the company 1 year after versus the current price. That is, X is given by share price 1 year after versus current share price. So usually what happens is that in this example, there will be a lot of irrelevant information. Well, because it's something that it can't be used to help you to do the question. So really what is the most important is actually any equation involved in this question. Okay. So in this question, part A, explain what an X value of 1.5 implies about a change in the price of one share over 1 year. So let's just take this as an example. We can say, well, copy the equation down. X equals to share price 1 year after over current share price. Okay. So when you look at this equation, you will understand, okay, so 1.5 equals to the share price 1 year after versus the current share price. So in that case, what we can say is that, well, I, so you could say the share price 1 year after increases by 50%. So it's like $2, for example, for the current price, and after 1 year, it will become $3. Okay, so continue from here. Now consider the situation that in such a large number of oil and gas companies, among all share prices, will let X be modeled by a non-normal distribution with a mean value of 1.25 and a standard deviation of 3.2. So we got a table of corresponding probabilities for mean X. Selecting X values is shown as follows. So from here, what we can say is that, well, I've got a table. So a lot of students might be thinking, okay, this looks like a discrete random variable question, or discrete or binomial or finding expected value question, because that's usually where you see a lot of tables being listed for the distribution. Well, this is not the case. Okay, it's trying to confuse you because, well, first thing we need to know is that, well, all these values contain decimals, so definitely not a discrete random variable. Also, because we're talking about share prices or ratios, it must not be a whole number. Okay, so therefore it must be a continuous random variable. Another thing to emphasize on this question is that we have, well, X to be all the share prices 1 year after, and also the corresponding probabilities. But here, this does not indicate X equals to X, but X less than X. So what it really means is that for the share price, or any randomly chosen company's share price, the price it will decrease to less than, well, 50% of the original price will have a chance of 50%. This is what it means, okay? So it also helps us to find a distribution of the curve, which indicates this is a non-normal distribution. Using all the information we have already got here, then we can say, well, find the probability that the price of one share in the randomly chosen company decrease over 1 year. So if it's going to decrease over 1 year, then we can say, basically, we are looking for the ratio less than 1. If it's less than 1, that means the price compare the price 1 year after, and now the price has reduced. That's why the ratio is less than 1. If it's going to be less than 1, a lot of students might be thinking, oh, according to the table, therefore the answer must be 0.15 because that's just less than 1, isn't it? Well, that's not right, because, like I said, this is not discrete random variable. So therefore we can say, well, x less than 0.5 is 0.15. X less than 1 is 0.45. Okay, so this should be exactly 0.45 because it's already indicated from the question. Also, some students might be thinking, should I add two probabilities together? Well, you shouldn't, because if you try to classify this, if you add all the probabilities together, this will be way beyond 100%. So that's not going to be a probability distribution. So what it really means is that, well, for the share values ratio, less than 1 already includes the probability of less than 0.5. To verify this, if you check this, so less than 3.0 is approximately or already approaching to 100%. So that indicates, well, less than 3.0 already includes all the other data's corresponding probabilities. Okay. Okay, to continue from the previous video, we want to work out the probability that any randomly chosen share will increase by more than 50% over 1 year. So having said all these, previously we find the probability that it's going to decrease. So this implies the x value less than 1. So in this case, we want the share price value to be increased more than 50%. That means we want the x value, the ratio, to be greater than 1.5. Okay, so using the same table, we want to find out the corresponding probability. But the common mistake that people might be made is that to add up the probabilities together from either 1.5 to 3.0 or 2.0 to 3.0. Well, like I said previously, you can't do that because this is inclusive. So the probability less than 3.0 already includes the 2.5 probability. So all we need to do now is we can do, well, if I want to find out the probability it is greater than 1.5, we can do 100%, which is 1 minus p x less than 1.5. So for the corresponding probability of x less than 1.5, it's already listed as 0.69. So 1 minus 0.69, and that will give us a probability of 0.31. Okay. Again, there will be a continuous question from the previous sections. So right now, we've got two investors, Mike and Hannah. Each person has exactly the same amount of money to invest in share market from these oil and gas companies. So number one, Mike decides to buy one share in each of the 100 randomly chosen companies. Hannah decides to buy 100 shares in one randomly chosen company. Assuming that the share prices are approximately the same at the time of purchase. So really what it means is the amount of money of spending on buying 100 shares from either 100 randomly chosen companies or 100 shares in one company will be exactly the same. So the total cost is the same, in other words. Okay, so what is really the main difference between these two types of investment options? So if Mike decides to buy 100 randomly chosen companies, so this indicates that Mike is taking a sample size of 100 from a large population of all these oil and gas companies. Hannah decides to buy 100 shares in one company, so that means a sample size of 1. So there's really no sample in this case. Alright, so number C, we want to let x denote the average x value of Mike's shares. So assume that x values of Mike's shares vary independently. We want to find out the mean and standard deviation in this case. Having said previously, we know that Mike is taking a sample size of 100. So this indicates that we should be using the central limit theorem. And central limit theorem implies that, well, the mean value is exactly the same comparing the sample and the population. So that in this case, we can say, well, mean for 100 equals to whatever the population mean is. And going back to our previous question, the mean value is 1.25. Okay? And also, the standard deviation will be given by the population standard deviation divided by square root of 100. So it was originally, I think it's 3.2. Just check. Yes. Over square root of 100. So that's actually 0.32. Okay. Well, after we found out the mean and corresponding standard deviation, the question is usually asking whether it is okay or reasonable to assume the sample size is large enough. And then this corresponds whether, well, the distribution of x is approximately normal. Okay, so because we use a non-normal distribution population to obtain the sample, so we need to make sure the sample size is large enough. So from all your textbooks, you will require to have a sample size n greater or equal to 30. Well, in our case, this is a sample size of 100. Okay, so yes, it is reasonable. Okay. Next, find the probability that the price of Mike's investment will decrease over 1 year. So after we have verified the sample size is large enough, then we can say, well, let y denote the price of share 1 year after for Mike's investment. So y will become a normal distribution. So central limit theorem states that, well, as long as you take the sample mean and the sample size is large enough, then therefore it must be a normal distribution, regardless whether you are obtaining the data from normal distribution or non-normal distribution. So the mean will be 1.25 and 0.32. So that's the mean, sample mean and sample standard deviation obtained previously. Okay. Now what happens is we want to find out the probability that y value will be less than 1, so indicates that it is decreasing. So we should be using your calculator. Okay, you should be using something similar to this. So let's just start from the beginning. Okay, you need to go to number 2, statistics. Okay, once you go to statistics, you have a few options to choose from. You should be using the distribution and selecting for normal distribution, and NCD is required. Okay, so we want y less than 1. So our lower value must be negative e to the power of 99. And our maximum value will be 1 because it's less than 1, and the mean and standard deviation is already set. So enter, and that actually gives us the chance will be 0.217. Okay. And going back to the next question, find the probability that the price of Mike's share will decrease more than 50%. Oh, sorry, will increase more than 50%. So that indicates we want to find Py greater than 1.5. So using similar analysis from the calculator, exit back. So this time we want to change the lower value to 1.5. And we want the upper value to be infinity, so e to the power of 99, so that's the largest value this calculator can actually take. Okay, so it equals to exactly the same thing. You might be wondering why, because obviously, because our mean value is 1.25 and it's obviously symmetrical for normal distribution, so the chance to be less than 1 and chance for greater than 1.5 should be exactly the same because they are the corresponding normal, symmetrical. So this is where you have the 1.25, and that's 1.0, that's 1.5. Okay, so this area must be exactly the same. Okay, after what we found, lastly, we want to compare what we found from B and C, so that we can tell whether there is any difference between the two types of investment options. So from B, we are completely relying on the non-normal distribution, which is whatever we obtained from the data group. So that's basically what Hannah did. Hannah is going to invest 100 shares in one of the chosen companies from here. Doesn't really matter how many shares she's going to buy, but really whether she's earning money or not, depending on whether she has selected any company that's, well, belongs to this range or this range, because that's where you lose money, that's where you actually earn money. Okay, So we have already found previously that the chance for Hannah to lose money is actually 0.45, and to win more than 50% of the original money, so that's like 0.31. So you can conclude like this. So there is higher chance or higher probability, okay, that Hannah investment decreases after 1 year in value compared to increase more than 50%. Well, but for my option, because it's symmetrical, so there's an equal chance. Equal chance that Mike decreases in value compared to increase by more than 50%. Okay, so when you get a question like this in the exam, try not to use any knowledge that you haven't learned from your math course. Maybe you learned something about economics or share prices. Doesn't matter. It's not something necessary for you to talk about. But really, you just rely on whatever you have obtained from your results and make a comparison. Okay. So this question actually summarizes a few knowledge points that you might encounter in a statistic question in the exam. So firstly is being able to effectively pick up the useful information from a lot of reading words, okay? Next is about whether you're able to clearly indicate whether it's a discrete random variable or dependent or continuous random variable, okay? And also obtain the probability from any table of data. Effectively apply the central limit theorem, find out the mean and standard deviation. Also use the calculator to calculate the probability from a normal distribution, usually obtained from your central limit theorem. And lastly, you should be able to effectively compare the data and interpret your findings. Okay.